So this is my demonstration for this coursework. And as you can see, I have already set this topology up, and I will try to explain step by step, try to achieve every criteria shown. So the first one I want to show you is that I've already achieved this criterion, so all devices in the above topology can communicate with each other. So let's talk about this some other details before set this up. What I did to set up this topology. So as you can see, I already created a logbook here and explain everything I did. So if I want to achieve A1 grade, so I need a topology like this. I need these devices. So I need the damn small Linux file to act as a client and a web server. So you can see here, I generate a new MAC address for all network adapters. Set up a Kiwi Syslog server Observium PF Sense firewall. As I already configure some of the settings of them before, so I just immigrate these devices I configured in previous labs and to this lab here. So for PF Sense, okay. So for PF Sense, we should have 3 network adapters and configured like this. So why do we have 3 network adapters in PF Sense? So it's only because this topology we need to connect the 3 line area. So I import them to the VirtualBox. I will show you here, and so here you can see I created all the devices and import them into the VirtualBox. So then I need to set them up in GNS3 and configure the network settings, of course. So I did them in the preference in GNS3 and move them to the topology and connect them. So, but what's important is here what I did for the network settings. So let's talk about a little bit about the network settings. Okay, before that, let's say we have a web server. Damn small Linux has a built-in web server, this monkey web server, so we can use it. So here we can see we have three line area. So this is the line area, this is the DMZ area, and this is external area. So we can see these 3 area connected to PF Sense. So first let's configure them. You can see I explained a little bit here, and I configured this here, so you can see that here they have the IP address assigned. So we also need to configure the R1 router 1. So router 1 I configure the router 1 interface. So you can see router 1 interface here. Interface. So overall, it has the IP settings LAN area 192.168.1.0, DMZ 172.16.1.0, R1 to TPF sense. This is 10.10.10.1. This is 10.10.10.2. And external has 192.168.20 settings. Yeah, here you can see here we can begin the initial setup for the pfSense. This wizard, we go to the web GUI. So here, I think it's here. Here this is web GUI of pfSense. So I access this web GUI from the Kiwi Syslog server, so because it's easy to access. We have everything, IP address. We have three IP three interfaces. And so that's the setup for this lab. And then we began to move on to achieve every goals we have in the labs. And so let's see the first one. All the devices in the above topology must be able to communicate with each other. So I did some things. I did several configurations here. So first thing I need to do is because here the pfSense is only able to see the devices, see the LAN area that it directly connected. So it must add a static route to here. So since I will show the static route here. So so routing here. Yeah, actually I configure the actually I only need to I configure here. So the network 192.168.20 is the external area. So I need to this it must travel through this to see the external network. So here I configured here. Also I need to router can see the LAN area. Yeah, same thing. We configure the router to see the local area through this through the pfSense. We also need to configure the R1. So I did some I configured this router. It has settings like this configure this IP address and configure this IP address, and also add a DHCP port to this IP address, so this external devices can get IP address from this interface. So overall you can, and then I also configure the pfSense firewalls, and you can see here firewalls for each I just configure the any source, any port, any destination protocols, SMP and TCP and UDP to allow these any packets travel through this pfSense so they can communicate with each other. Yeah. Yeah, we also need to configure the router to see the DMZ area. So we need to add a static route. Yeah, this is a firewall that set in the firewall rules that set in the PF sense. So let's begin to demonstrate so they can communicate with each other. So since there is a lot of devices, I just need to demonstrate. For example, this web server can can get to this web server. This web server can get to each other. The first is the external web server address. Here we have firewall folks. External firewall, internal firewall, and DMZ firewall. So this, for example, this IP address is 192.168.1.1.0. See, we can get this web server. I've already started all the web service of these devices, and also try to reach this one. Yeah. One. See, you can see it can also reach this web server. Means they can communicate with each other, of course. And for example, this one try to reach this internal. Yeah, so that's so it means we successfully achieve these settings. We can ping the interface works well. I don't remember the dot two dot 10. Is it 10? I don't remember. Stuff one PC should be stuff one PC. This external web server. Yeah, 192.168.22. 192.168.22. 23. Yeah, 23. So they can communicate with each other. So here, our second aim is to let both web servers send their syslog traffic to the Kiwi Syslog server. So first, what we should do is edit the etc host file. So add the IP address and syslog host name to this file, and then edit the syslog config no, syslog config file, and add the message to this config file, and then since we already let them to be able to communicate with each other, so well, we have already started the syslog server manager in the machine, and then we can start the service by type the syslog d -r syslog. So this is I think this is unique for the damn small Linux. It's unique for this Linux distribution. So here you enter the command and you can see the new message appears in the console. And you can keep testing it by entering logger some whatever you want to send the Kiwi Syslog service. So so this is the first web server, and we did the same thing for the second web server. So we have already edited the host file and the syslog config file. So we just started the service by entering the same command we entered before. So we entered here, and you can see the IP address, the same 192.168.1.1101. The syslog service started. So we can test it by enter the commands. This message is sent to the Kiwi Syslog service manager. So by now we've achieved the second aim. Both web servers should send their respective syslog traffic to the Kiwi Syslog server. So this is the second web server. This is the first web server. So here, our second aim is to let both web servers send their syslog traffic to the Kiwi Syslog server. So first, what we should do is edit the etc host file. So add the IP address and the syslog host name to this file, and then edit the syslog config no, syslog config file, and add the message to this config file, and then since we already let them to be able to communicate with each other, so well, we have already started the syslog server manager in the machine, and then we can start the service by type the syslog d -r syslog. So this is I think this is unique for the damn small Linux. It's unique for this Linux distribution. So here you enter the command and you can see the new message appears in the console. And you can keep testing it by entering logger some whatever you want to send the Kiwi Syslog service. So so this is the first web server, and we did the same thing for the second web server. So we have already edited the host file and the syslog config file. So we just started the service by entering the same command we entered before. So we entered here, and you can see the IP address, the same 192.168.1.101. The syslog service started. So we can test it by enter the commands. This message is sent to the Kiwi Syslog service manager. So by now we've achieved the second aim. Both web servers should send their respective syslog traffic to the Kiwi Syslog server. So this is the second web server. This is the first web server. Next, let's move to the fourth aim and the fifth aim. Let's say the fourth aim is for configure the pfSense to block all the all the external traffic and allow start PC1 to communicate with DMZ web server. And B1 configures the PFC device to allow external traffic to communicate with the DMZ web server. So now I put them here to achieve these two aims together, because my topology is my topology here. Let's see. My topology here actually is the final topology. It contains everything, and now they already be able to communicate with each other. All I need to show is first first block the external traffic and allow external traffic, and then yeah, that's the aims. So first let's show here to block the traffic. Here they now are able to ping to ping each other, so they can communicate with each other. So all the ping here, this is the external web server. So if he wants to ping the internal web server and the DMZ web server, 172.168.110. So you can see actually they can ping each other, and this ping the DMZ server, ping the internal web server, so they can ping. They can communicate with other line area, other subnet. So if I want to block it from entering it, the only thing I need to do is in the firewall rule here. This is because it's external is in one subnet. All I need to do is enable this rule. So what about this rule? What is like? So this rule is block. Block. What means block? Block the packet is dropped silently. So the traffic are blocked. Protocol set to any. So source network set to a network. So when I to the external IP address should be 192.168. 192.168.12.0. 24, yeah. So here I save it, apply. So we try to ping it again. So we can see now the external traffic are blocked. Like yeah, we can't access the other subnet anymore. So let's see this is the first aim, block the traffic, but stop PC1 to communicate with the DMZ web server. The line error can still be able to get the DMZ web server, because I didn't do anything to block the DMZ web server. As you can see here, yeah. Let's see, this is 172.68.10. Firefox 1.1. Yeah, so they can still communicate. So that's I completed the first thing. So for B2 grade, right? No. Okay, for B2 grade, I need to configure to allow external traffic. To allow external traffic all I need to do is just disable this rule. Disable this rule, yeah. Disable this rule. disable this rule and okay, disable this rule. And let's try the external web server. External web server. Client PC. Oh, it's fine. Yeah. You can. Oh, okay. External web server. Yeah. Try to ping it again. Yeah. So external traffic are no longer blocked. It can ping the DMZ area and the local area network as well. Not allow travel to communicate with DMZ web server. So we will achieve these two aims now. Yeah. Okay, let's move to the final three aims. Then the first is configure the PFSense device to allow syslog traffic from DMZ web server to Kiwi Syslog server. So we already did the already you can see the actually it can ping the they can communicate they can reach to the syslog server. So all it needs to do is use the syslog command, which I think it's very old syslog D version for the damn small Linux distribution. So I've done it. You can just enter this command, and then in the Kiwi Syslog server you can find the the syslog D service started, and you can then enter send the syslog message to it, for example. Yeah. So that's this aim. Very easy. Allow syslog traffic from DMZ web server to Kiwi Syslog server. Yeah, it's very easy. Then configure the PFSense device to allow PC2 to communicate with both DMZ's web server and external web server. Yeah. This was done at the very beginning. Yeah, they can communicate with each other, as I said. So you can here he is trying to reach the external web server, I believe. External web server here. Yeah, he's trying to external web server 192.168.2.2. DMZ web server here. Here, yeah, here. 172.161.1.12. Yeah, you can reach these two web servers in other subnet. Finally, configure the PF device to allow external staff PC to communicate with any internal company devices. As I said before, I added the static routes to allow the external clients to reach any device, to reach the internal to reach the line network, which includes any devices which is in line network. So for example, I want to reach the staff 1, I want to reach the staff 1, staff 2 in the line area, and staff 2, where is the staff 2? Didn't start at staff here. Staff 2 area. So one is staff 2 is 192.168.1.1013. This is 102, I believe. Yeah, 102. So for example, here, one, no, 191.1.1.1. Yeah, so I can pin both of them because here you can see and show IP root. See this this is the here no here static root via this IP address, which is the next hoop IP address of IPsense interface's IP address. So above all, I believe I achieved everything listed in this lab. Yeah, everything. To allow external piece. Let's see. External stuff PC. Stuff PC, okay. So stuff PC is same. Stuff PC. External stuff PC. Yeah, show you. Okay, I will try to start it. Stuff PC is the same. Go to the IP address root. Yes, I remember the password. Yeah. Getting the IP address. Yeah, where? Pin 192.168.1.1. Yeah, so you can see successful, successful, successful. Okay, so that's all. Thanks for your listening. Yeah. Okay. Thank you. Much appreciated.